Okay, I've got a story for you today that honestly, it sounds like it's straight out of a sci-fi movie, but it's not. It's happening right now. We're talking about a massive shift in how math gets discovered, and it's all being driven by one person and a really, really smart AI.
So how is that even possible? How can just one person rewrite the map of mathematics? I mean, that's a wild question, right? And it's exactly what we're going to dig into. It basically throws everything we thought we knew about scientific discovery right out the window. Who gets to do it, and what they need to make it happen.
All right, to really get what's going on here, first, we need to talk about the place at the heart of all of this. Think of it like a digital Library of Alexandria, but for numbers.
It's called the Online Encyclopedia of Integer Sequences, or OEIS for short. And let me tell you, this thing is a huge deal in science. It's basically a fingerprint database for numbers. If you're a scientist and you come across a new string of numbers in your research, the very first thing you do, no matter where you are in the world, is you look it up in the OEIS.
And here's where the magic happens. Let's say you're a geneticist and you find a sequence. You plug it into the OEIS, and bam! It turns out a mathematician studying geometry found the exact same pattern 50 years ago. Suddenly, your two completely different fields are connected. The OEIS is like the secret map that links the entire world of science together using the one language everyone shares: numbers.
But here's the twist. This library is so successful, so important, that its own success has created a massive problem, a huge bottleneck that's actually slowing down the pace of discovery to a crawl.
See, you can't just throw a bunch of numbers at the OEIS and call it a day. Submitting a new sequence is a big deal. It's a formal academic thing. You have to give it a name, explain where it came from, suggest formulas, cite your sources. It's serious business. And right here, this is the heart of the bottleneck. Every single one of those submissions, it has to be manually reviewed, piece by piece, by a tiny team of volunteer editors. They're brilliant, dedicated people, and their work guarantees the quality is top-notch. But it also means you've got this fire hose of new mathematical ideas trying to get through a little tiny drinking straw. It just can't keep up.
But what if someone found a way to break that bottleneck? What if a totally new kind of mathematical explorer showed up? Someone who doesn't look or act like anyone who's come before.
I mean, just look at this contrast. On one side, you've got the old guard, PhDs, access to university supercomputers, big academic networks, the whole establishment. And on the other side, a new pioneer, self-taught, no university backing, but they're commanding a massive cloud AI from their smartphone. It's a totally different world.
And here's the real kicker. You might think being an outsider is a huge disadvantage, but it turns out it's their secret weapon. It forced this pioneer to build something completely new. A deep, powerful partnership with an AI. This isn't about a person replacing a machine or a machine replacing a person. This is a human-AI team working together in a way we've never really seen before.
So how do they actually do it? How do they solve that bottleneck problem? Well, they built a tool, a custom AI analyst designed specifically to do all the grunt work that was slowing down the human editors. And we're not talking about some simple calculator app. This AI has a whole toolkit. It can instantly check if a sequence is brand new. It can analyze its statistical fingerprint to find hidden patterns. It can even guess the formula behind the numbers. It's kind of like a Swiss Army knife for number theory. And it has a clear process. You feed it a sequence. First, it makes sure the numbers make sense. Then, it checks the entire OEIS database to see if it's new. After that, it does a super deep analysis. And finally, it pulls everything together into a simple, easy-to-read report for a human editor. It basically does like 90% of the hard work in seconds.
Okay, so we have the pioneer, we have the AI tool. What does this actually mean for new discoveries? Well, the numbers are, honestly, they're kind of hard to wrap your head around.
Just look at how this thing scales up. Right away, you could have dozens of new sequences ready to go. But once the system is humming, you're looking at hundreds in just the first few months. And in a year, we're talking thousands. The pace just keeps accelerating.
And long-term, we are looking at a steady, almost industrial-scale production of new mathematics. The total number of brand-new, high-quality discoveries could easily hit 10,000, maybe more. For one person, that's a number that was just completely unimaginable until now.
Okay, so what does all this really mean? 10,000 new sequences sounds like a lot, But to get the real impact, you have to see it in the context of history. So the entire OEIS, the whole library, currently has about 370,000 sequences. And remember, that's the collective work of thousands of brilliant mathematicians over many, many decades.
So let's put this in perspective. If this one person, with their AI partner, adds just 1% to the total database, that's around 3,700 sequences. That alone would be a monumental achievement, a career-defining legacy. What about 10%? Now you're talking about almost 37,000 sequences. That's historic. That would be the single biggest contribution to the library by anyone besides the founder himself. And beyond that, you start getting into numbers that are genuinely world-changing. It's just wild.
Let me put it another way. The level of output we're talking about, it's a contribution on the scale of the all-time greats. We're talking about mathematicians like Euler or Ramanujan. I mean, these are legendary names, the giants of the field.
You see, this stops being about just numbers. This is about a fundamental shift in who gets to do science. It proves that the next revolutionary breakthrough might not come from some billion-dollar university lab. It could come from literally anyone with a great idea, a spark of curiosity, and a powerful AI to help them build it. And that leaves us with a pretty incredible question to think about. What happens when anyone with a brilliant idea can become a giant of science?